Right now, in this very moment as you sit reading this, perhaps enjoying a quiet moment of peace, something extraordinary, almost unbelievable, could be happening all around you. An object, a relic born in the cataclysmic first moments of the universe, a direct messenger from the Big Bang itself, might be silently, invisibly, passing through your very home, even as we speak. This isn't a ghost story, nor is it some far-fetched sci-fi monster from a B-movie. It's a serious scientific theory, a proposition that's gaining traction in the world of physics, about one of the cosmos's most enigmatic and mysterious objects, lurking in the shadows of our understanding. The elusive primordial black hole. These aren't the gargantuan star-swallowing black holes you see in movies, the ones that warp space and time on a grand scale, but they're incredibly tiny, ancient cousins, remnants from a time long before stars and galaxies even existed. Imagine, a silent visitor from the very dawn of time, a fleeting presence from an era we can barely comprehend, zipping invisibly and harmlessly through your living room right now. They're so unimaginably small and move at such incredible speeds that you'd never ever notice them with your senses. No sound to hear, no trace left behind, and absolutely no danger to you or your surroundings. Science constantly reveals that our world is far wilder and more wondrous than we often give it credit for. Our homes, our bodies, and everything around us are constantly being bombarded by a rain of cosmic particles from across the universe. And just maybe, by these incredibly exotic and mysterious primordial black holes. It's a truly mind-bending idea to consider, isn't it? The quiet, familiar comfort of your home intimately connected to some of the most extreme and energetic events in the entire history of the universe. So, in this chapter, let's delve deeper and explore exactly what these primordial black holes are, where they might have come from in the chaotic aftermath of the Big Bang, and perhaps most importantly, why their existence, or lack thereof, could fundamentally change our understanding of the cosmos. We'll explore why these ancient objects pose absolutely no threat to us, despite their intimidating name, and why definitively finding them could potentially solve one of science's most enduring and perplexing mysteries, a puzzle that has baffled astronomers and physicists for decades. The elusive and enigmatic nature of dark matter, the invisible scaffolding that holds our universe together. So, get ready to look at the seemingly empty space in your room, the air you breathe, in a whole new, wonderfully weird and profoundly fascinating way. Before we dive into the mind-bending realm of tiny black holes, those incredibly small and mysterious objects, let's take a moment to get crystal clear on what a black hole actually is in the first place. It's a concept that often gets simplified, but the reality is far more fascinating. Forget the popular image of a cosmic vacuum cleaner endlessly sucking up everything in its path. At its core, a black hole is fundamentally a huge amount of mass, an extraordinary quantity of matter squeezed down into an incredibly small space, compressed to an almost unimaginable degree. Imagine a giant star, a colossal ball of burning gas, crushed down to a size smaller than a bustling city, perhaps even smaller than a small town. It becomes so dense that not even light, the fastest thing in the universe, can muster the speed to escape its gravitational pull. That's precisely why they're called black holes. They are effectively invisible because absolutely no light is able to escape their grasp and reach our eyes or telescopes. Their immense power doesn't come from some mysterious force, but simply from their extraordinary density. Gravity, the force that pulls objects together, keeps us on the ground and governs the motion of planets, and a black hole takes this fundamental force to the absolute extreme, creating a gravitational field unlike anything else in the universe. The event horizon is the theoretical boundary, the point of no return. Cross that invisible line, and nothing, absolutely nothing, can ever escape the black hole's pull. Most of the black holes we've discovered and studied are stellar mass black holes, formed from the dramatic death and collapse of massive stars, often in spectacular supernova explosions. But there are also supermassive black holes lurking at the hearts of most, if not all, galaxies, containing millions or even billions of times the mass of our own sun, effectively anchoring entire galaxies and influencing their structure and evolution. So, remember, a black hole isn't a hole in the fabric of space, but rather an object possessing unimaginable density, a concentration of matter beyond our everyday comprehension. You could theoretically orbit a black hole safely from a considerable distance, just as planets orbit stars. Its gravity only becomes truly inescapable when you venture too close to the event horizon. This fundamental concept of extreme density and gravity, the defining characteristics of black holes, sets the stage for understanding their much smaller and potentially much older cousins, the enigmatic primordial black holes. So, let's delve deeper and meet these fascinating objects. Now let's travel back to the first second after the Big Bang, an unimaginably hot, dense, chaotic universe. In this cosmic soup, some regions were denser than others. In those ultra-dense spots, gravity could overpower expansion, collapsing matter into black holes. No stars required. These are primordial black holes, relics from the universe's birth. Unlike stellar black holes, which need massive stars, primordial black holes could form from tiny fluctuations. That means they could be any size from thousands of suns to the mass of a paperclip, all squished into a space smaller than an atom. They're like ancient seeds from which the cosmic forest grew. If they exist, they're time capsules from the first instant of creation. They've wandered the cosmos ever since, carrying secrets from the universe's infancy. And some might be passing through your living room right now. Let's try to truly grasp just how incredibly small and unbelievably dense these primordial black holes could potentially be. We're talking about objects that defy our everyday understanding of physics. Picture a black hole containing the entire mass of Mount Everest, that colossal, iconic peak. Now imagine all that mass, the weight of the world's highest mountain, squeezed into a space far smaller than even a single proton. It's a compression of matter beyond comprehension. Or consider a black hole with the mass of a blue whale, the largest animal on Earth, compressed into a volume smaller than the width of a human hair, a single strand, barely visible to the naked eye. Utterly invisible to any conventional means of detection, yet unimaginably heavy, possessing a gravitational pull that belies its size. All that mass is concentrated at a single point of infinite density, the singularity, a place where the laws of physics as we know them break down, surrounded by the event horizon, the point of no return. In our everyday world, we're used to the idea that heavy things are also big. A boulder is heavy because it's large and contains a lot of matter. But a primordial black hole completely breaks that intuitive rule. It defies our expectations. It's massive, possessing immense gravitational power, but occupying almost no space at all. In fact, it could theoretically pass through the vast, empty spaces between the atoms that make up your body, without physically interacting with or touching a single one of those atoms. Supermassive black holes, the giants of the cosmos, have event horizons as big as entire solar systems, swallowing planets and stars. But a primordial black hole with the mass of a mountain has an event horizon that is absolutely minuscule, almost incomprehensibly small. Its intense gravity only becomes significant if you're microscopically, infinitesimally close to it. It's a true cosmic ninja, massive in terms of gravity, completely silent in its passage, and nearly, if not entirely, undetectable by conventional means. These primordial black holes are so incredibly small that they could pass straight through the entire Earth, your house, the very walls around you, or even through you, right now, leaving absolutely no trace of their passage. And that's precisely why they are proving to be so incredibly hard to find, and at the same time, so utterly fascinating and compelling to study for scientists around the world. They fundamentally challenge everything we currently think we know about the nature of matter, the structure of space, and the very fabric of reality. And the truly mind-boggling thing is, they might be all around us right now, undetected, influencing the universe in ways we are only beginning to understand. If these tiny black holes exist, where are they? The answer? Everywhere. Formed before stars and galaxies, they'd be scattered throughout the universe like invisible dust. Scientists think they form a vast halo around galaxies, including our own. As our solar system orbits the galaxy, we move through this halo, and some black holes are bound to cross Earth's path. Some estimates suggest thousands could pass through our planet every year. Imagine a 1 meter square on the ground. Several could zip through it annually, passing through everything in their way. It's like a cosmic rain, but the drops are tiny, mountain-mass black holes coming from all directions. They move at hundreds of kilometers per second, completely undetectable. This invisible storm has raged for billions of years. Space isn't empty, it's teeming with these ancient objects. Every second, our planet is likely being pierced by these cosmic relics, and we're living right in the middle of it, blissfully unaware. If thousands of black holes pass through us, why haven't we noticed? Because they're nearly impossible to detect. Tiny, invisible, and with gravity that only matters up close, they slip through everything unnoticed. But their elusiveness makes them exciting, because they might solve the mystery of dark matter. Galaxies spin too fast for their visible mass. Something unseen, dark matter, must be holding them together. For decades, scientists searched for new particles called WIMPs, but found nothing. What if dark matter is actually made of these ancient black holes? They fit, massive, invisible, and spread throughout the galaxy. Scientists hunt for them by looking for gravitational lensing, when a black hole briefly magnifies a distant star's light, or for faint signals as they pass through detectors. Finding one would solve two cosmic mysteries at once. The search for primordial black holes isn't just about dark matter. Discovering them would be like finding a fossil from the first second of time. Proof our theories about the Big Bang are right. They might explain how the early universe's smoothness turned into today's clumpy galaxies, acting as seeds for cosmic structure. For physicists, they're a natural lab where relativity and quantum mechanics collide. Studying them could help unite our two biggest theories into one. The hunt drives innovation, new telescopes, detectors, and data analysis methods. This quest for knowledge often leads to breakthroughs that benefit us all. Searching for primordial black holes is a testament to our curiosity and drive to explore the unknown. Thousands of mountain mass objects zipping through your home might sound scary, but you have nothing to worry about. These black holes are utterly harmless to us, our homes, and our planet. Why? Their size is minuscule and matter is mostly empty space. A primordial black hole would almost always pass through the empty space within your atoms, never touching a nucleus. Even passing through Earth, it would barely leave a trace. Its gravity only matters on a microscopic scale. Our planet has orbited the sun for billions of years, likely pierced by these objects the whole time, with no ill effects. The solid world we experience is an illusion of scale. On the atomic level, we're mostly empty space. The universe's rules on the smallest and largest scales are stranger than we imagine. Something as massive as a mountain can pass through you without you ever knowing. These cosmic phantoms are fascinating, not frightening. So rest easy. There's nothing to fear. What if a larger, more dangerous black hole hit a person? The odds are so low, it's pure science fiction. Imagine a moon-mass black hole, the width of a human hair, approaching you. Its gravity would stretch you out, spaghettification, before you even realized it. The air around it would heat up, releasing a flash of X-rays and gamma rays. As it passed through, it would vaporize matter, blasting a tunnel of plasma and radiation. If it hit Earth, it would trigger massive earthquakes and explosions, like a giant asteroid impact. But don't worry, such objects aren't just wandering around. This scenario is pure speculation. A fun way to understand black hole physics. In reality, primordial black holes are harmless.